We do have a lot of ideas, requests for medical applications, and we do give our best to find solutions which are novel at this stage. And we keep running into some problems over and over again, which are usually not on the client side, but are generally in the medical world. And in some ways, the world is not ready for our engineering solutions. So my idea was, let's go through several use cases why these won't work today, might work very soon, what we need to change, and then I want to show you a use case that I believe can work right now, and I'm kind of passionate about it. This is my history and how I was introduced to AI while I was studying medicine. First of all, this is something you've probably seen many times. This is an example of a printout of an ECG, 12 channel. Seems kind of complicated. Also, who has this laser? I want that, Tina. Thank you. And yeah, here it is. Very common. Just so you know, this is. I'm not sure when this was recorded, but I've seen things like this 20 years ago while studying. Even then, you had some semblance of AI giving you suggestions for diagnoses. We were instructed very firmly that we shouldn't be looking at this as students or as doctors because it's all completely incorrect. It did tend to give quite a few additional diagnoses. It was kind of sensitive more than specific. But the point is we weren't allowed to take a look. There was some kind of doubt even then in the medical community. And then 20 years later, a friend of mine is actually sending me, we're discussing, I'm saying, what are you doing when you have those Holter monitorings for 24 hours, you have printouts, you have data, you want to catch that tiny sliver of arrhythmias happening. And then she's like, no, it doesn't work. I'll show you. So these horrible screenshots, they're her angry screenshots, saying, can you believe this? It's actually finding some of them well, but then it's missing the huge ones and then labeling those just next to it. This is clinical software. I have no idea which one. I don't know what's the underlying algorithm. I do believe it's not any sort of deep learning, which makes this a solved problem today, but this is clinical practice. And I can understand why somebody would be reluctant to use it. Then, if you go and take a look at the timeline of AI applications. This is Mount Sinai website, a huge hospital and very influential one regarding technical stuff in the US. You can see this timeline, which starts, this is from 1991 to 2022. First of all, many of these things are not really AI. So the Human Genome Project, it has nothing to do with AI. It's the first time we read the Human Genome, impressive, no AI whatsoever. We use it in classical bioinformatics. And as you can tell, there are, here and there are excellent applications. First of all, I've never heard of any of them or seen them applied. So this should, in my opinion, indicate some sort of sparsity in this space. First of all, there are huge gaps before. Now we do see that starting from 2017, which is likely application of deep learning, we do see this getting more frequent, but still this is in a very bad place. What I want to show you, we do use something that's broadly classified as AI in medicine. Usually risk scores or simple linear models, they're easy to interpret, they're easy to extend, and easy to verify later. Not good. And then one of the reasons why everybody says that we cannot rely on AI is doctors keep repeating that we don't know the context, that the medical context is something uniquely human and held by the doctor, which is, we can argue that. It definitely, the context is important. And this is an example where somebody used to say that this is something that an AI could never solve. We can discuss this as well. But you see, this is these are printouts of certain ECGs, and then you see that in addition to these big heartbeats by the patient, you have these tiny ones marked by the black spots. They're kind of more frequent, but still irregular. And this is an unusual, you can see this happening here as well, or here. Do you have any idea which disease this is? Somebody? You've never seen this? It's the most beautiful disease in the world. It's actually pregnancy, and near the end, after something like 36th week, you can actually see the baby's heartbeat in the mother's ECG. And this is, it's correct. It needs context. On its own, it's nothing. But I'm not quite sure that using an EHR, electronic health record, and saying somebody's pregnant, I'm not sure that that's such a unexplainable context to a person or an AI. So this was, the introduction was kind of just for me. I teach biostatistics at the University of Belgrade, and I teach it to doctors. So I will be having these fun slides because I've never seen a doctor who can listen to you for 45 minutes. So please bear with my tone. This is, there are a few case studies for AI that came to mind during COVID and afterwards, after the appearance of first ChatGPT. We had a colleague who is from sales who reinforced his pitch by saying that he got pneumonia. And he was in the hospital and he was checking everything the doctors did. He was checking it on ChatGPT, verifying the therapy and everything. And it wasn't very difficult, so there was nothing unusual about his therapy. It was supportive, business as usual. But he said that he was very confident about his diagnosis because there was an agreement between the doctors and ChatGPT. So kind of he verified all of that. So I was like, yeah, that's cool. I thought that maybe he verified ChatGPT as a good chatbot in that situation. But I'm not quite sure. I think that he actually meant that he verified the doctors. I think that he trusted ChatGPT more than Serbian medicine. And so I was wondering how would that look. Initially, when he told me that, I wasn't paying for ChatGPT. So 3.5, this is what's happening on the left. You can see there is a lot of information, and for this kind of uncomplicated pneumonia, it's, I think any of you could have said something similar, maybe not phrase it as nicely. Now, 1 year afterwards, you can see that with the same prompt, you get a bit more, first of all, it's a bit more parsimonious, as we would call it, so it's to the point. And then this is new, from my perspective, actually the links and sources, which are basically an add-on at the website, and as far as I know, not available via the API. It's good. It's working good. I'm not sure that this is actually a case representative of a problem we have in a clinical setting. Just so you know, if you've read Hyperion, you might remember from the end, this is an unusual situation. You have the situation of Abraham sacrificing his son to appease the God. God was testing Abraham to see if he is loyal enough. And in that book exclusively, there is a twist saying that maybe Abraham was testing God to see, would the righteous God allow you to sacrifice your own child? Maybe this is the kind of situation. Who is testing who? Are we testing ChatGPT with human domain knowledge? Or are we trusting the AI to verify what's happening in our real world? That's interesting, in my opinion. Who is being validated? Just so you know, when we put into solutions, we actually empower the patient. We can empower the doctor. Usually, just briefly, we usually focus on the patient health, especially with the US companies. They always make startups directly catering to patients. I do believe that empowering doctors is kind of much more important, because patient, they do need, this is an application directly by patient bypassing the doctor. And patients need a lot of interesting things, and it is true that this holistic approach is probably not available in as we call it, classical modern medicine. But still, I think that we are very far from replacing proper medical care. But some use cases. If we need a holistic approach, there's something empathy, bedside manner things. let's wonder for the first use case, can an AI provide that? So doctors obviously cannot. This is an early idea. First of all, ELIZA is actually the name, if you remember, of the first language model developed in the mid-20th century. This is a video game, maybe you've seen it, maybe not, that actually hypothesizes a world where you have a very advanced AI doing psychotherapy for you. And then you play as a person who is actually some sort of a puppet in a way. So people might feel awkward chatting with interfacing with an AI. So you are basically a person who is listening, completely following all the prompts. You are being prompted, not the LLM. And then you're just saying, so it mimics the human experience, but all the decisions are being made by the AI. It doesn't matter, but it's an interesting concept. At some point, you do have some ideas that you should proceed differently. And then the question arises again, like what do happen when you have a mismatch between artificial intelligence and the human expert of some sort? And one could say that emotions, that many people are experts on human emotions. This is a very specific use case. Mental health is kind of problematic. I'm not sure if you knew about that. So in addition to that international classification of diseases that's being updated every few years, there is a separate DSM, which the 5th edition is now in print, in use. And it's interesting, prior to it, at the conference there was a fantastic talk saying what the goals are for that. I'm not sure if you knew that, but there isn't a psychiatric disease that actually has a biomarker. When we say biomarker, there's nothing you can strictly, objectively measure. So your transaminases, something in your blood, whatever, when you do blood work for depression, for something, there is nothing you can measure that actually is the herald of that disease. And there is a lot of stuff going wrong. For example, in depression, you have a very bad glucose profile similar to diabetes. Everything is shutting down slowly. So it's not a question whether you have a reflection of your mind on your body. The point is you don't have a diagnostic method for that. And they were hoping to provide that by DSM-5. It's set as a huge goal of psychiatry. We're not there yet either. So nothing, genomic studies, RNA, DNA, we're still not there yet. So this is kind of a soft field. And something, the softest AI yet, like LLMs, it's normal to think about the application there. Of course, we do need some formalization in it. And there are fantastic papers published out there, always. But I just want to show you like an example. This is a group from Stanford, publishing in Nature, doing very well. But it's still, their papers are again soft. This is not a real formalization. Their task is not easy, mind you. But you can tell that they are discussing possible applications like psychoeducation, reframing thought. This is something we do for emails as well. Then they compare it to self-driving vehicles, which is not a good example because that's so easily measurable and so objective, like whether you hit somebody or not. And then they have these key points, and this is just from an article in Medium, saying that Jung is actually mentioned a lot in this case for some reason. But they do feel that this is coming. We're just not sure how, why, or when. There is a good paper. Just pay attention. There is a good paper, in my opinion. First of all, it's cool looking with all these kind of drawn things. I thought that maybe this helper thing is an error, you know, when you use DALL-E or any kind of generator and then it gives you bogus words. It's not, it's the name of their assistant. And they did try to do some numerical data to make a formal analysis of the performance. It's based on a questionnaire. So it's, again, there are layers of subjectivity there, but at least it's something. It is an instrument. So this is something that I applaud, and you should as well. We want to see some hard data, not just like general vague descriptions. And then this is a second case study. After this, a friend of mine called me and said, "Hi, Ogi. You see, can we take our daughter skiing? She's 1 year old, but it's a high mountain. It's 2,300 meters." And he said, "Do you have a good pediatrician we can ask?" And then I was like, "Your daughter is 1 year old. I mean, by now you should have a good pediatrician, right?" But actually, I was kind of dismissive, I think, and he said, "Yeah, our pediatrician was also dismissive." But then there was our cousin, who's an old school guy. He was like, "Yeah, you shouldn't do that to a child." Again, you can ask ChatGPT. It changed a lot. You can see the early response, the next one. But it's interesting that ChatGPT became more prescriptive. I'm not sure if you can tell. So in addition to just saying, describing the problem, this is can be safe. This is prescriptive, guys. So it's saying, it's approving your idea about the child. I think that it's quite safe and it's okay. But I feel that this is kind of a huge change in 1 year. Testing these LLMs to see what's going on and what the result of the formalization I was talking about, it's difficult. And this is just one of the interesting division of the things you can test. But if you remember, I started this whole thing but the emotion, can you actually get the bedside manner you need? Talking about with people prior to this conference, people were saying that they know people who actually use ChatGPT for some sort of emotional support. And yesterday I saw a new subreddit mentioning that. Nothing interesting to show, but people are relying on it. Just showing you an interesting find. This is called Emotion Bench. It's used for benchmarking emotions in LLMs. And it's interesting, setting the tone is quite interesting. There are also systematic reviews, which are done by humans, testing the ability and sometimes specifically empathy of AI, which is something that's kind of considered missing. I tried telling it to be more empathic in both cases. The early model became useless. So the empathy in ChatGPT 3.5 was just really emotional support talk. Well, I find that now it changes the tone very well. The progress is amazing, in my opinion. It still gives you exact data, although framing it in this bundle up and this kind of warm language. But take it slow, but still it gives you pertinent information. So the progress is awesome. And it's definitely, while here you could say that there is no empathy, it's more up for discussion now. Interesting thing, 2 months ago, there was a discussion in a conference in Melbourne, and there was a physician saying, when everybody was criticizing the use of LLMs in clinical practice, this is an interesting idea. A person stood up, he was a gastroenterologist, I think, and he said LLMs cannot be used successfully as they do not understand the medical and physical context of the patient and the hospital setting. And initially everybody was bobbing their heads, and I was like, yeah, correct, they don't. But if you think about it, this is correct for a doctor making a quick decision, ER of some sort. You don't have the time to describe, he won't be able to see, touch, smell, everything you're seeing. But this is not the common medical experience, in my opinion. So you go to a doctor, you have an initial checkup, you get therapy, you're back in 3 months. The doctor forgot all about you. Maybe you're seeing a different one. And what you have for context is medical documentation. And I feel that this is not really the problem of ChatGPT, it's the problem of medical documentation. So somebody is pinning all the problems on LLMs at this point. You can see that medical documentation is something being developed in a very active field of research. So this is just on PMC, so the free PubMed papers, and you can see that just in last year there are 23,000 papers dealing with this. And also in the first 3 of them, you can see the third one is already testing ChatGPT to create structured medical data. And then this is just as an illustration from Wikipedia. These are all the open source EHR implementations for different standards. There is a lot of research going on here. And I feel that we are unfair when we say that ChatGPT doesn't understand the context. It's the first AI model that actually can understand the context if you wrote it down properly. So can you do something about that? Mr. Gastroenterologist, can you maybe write it up properly? Of course, the concern that they should have is we need to test it, we need to formalize it. This is what we're revolving around the whole time. And the reason is, so for example, this is the paper from 2012, 13, 14. It's relatively old. It's an extension of a well-known instrument. It's used for assessing the quality of documentation. And it can be, again, a questionnaire. It is kind of appropriate for this. And then we use this instrument, this tool, to test our new tool, ChatGPT. And you can see that, they took 14 cases and then they reviewed it with PDQI-9. These are okay scores, so I couldn't find the maximum score here, to be honest. And it doesn't really matter. The point is it's very variable, and they found that it's not very good. Also, they said that it performs better in subjective areas, in objective areas than in subjective ones, which might have something to do with the assessment as well. But actually, this is a good direction to take. But I want to emphasize something that might not be clear. We are testing ChatGPT. We are not easily testing our doctors, because that would be unethical. Because putting somebody up and then testing them, having their results, and showing that they are relatively bad at doing their medical work is kind of problematic. ChatGPT doesn't get offended. And you know, it should be something like your ego shouldn't be important in this kind of thing, but it is. But everybody's reluctant to do studies like how well our doctors actually write medical documentation. I'm not suggesting we should go head-to-head with them. What I'm saying is, when you're testing, you're actually quantifying ChatGPT. You're not quantifying the clinical practice. When you're not measuring something, you're always assuming 100% accuracy. And this is simply not correct. Another concern that should be, this is relatively old, from Llama 2, but we don't know what's going on with ChatGPT. In addition to not knowing how it's trained and all the major stuff, we won't be knowing it. This is just an example. Many of you have probably seen it. This is when you query the API directly. You don't have the website. Their website does so many things for you. It has additional models. It gives you references. It splits your input into 3 parts: the user, assistant, and system. So when you say like writing haiku or give me an answer in emojis as part of your prompt, it's actually being split and sent to a specific system prompt. And the point is, not only do we not know what's going on in the model itself, we don't know what's going on in the interface and all the layers between, and we won't be. Maybe you know better than I do. I spend so much time in OpenAI forums that everybody's just guessing, and this is not okay for medical stuff. So it's not the fact that it's a black box as a model, which is frequently said. Everything is a black box. Like, we only know, like, we see Sam Altman and we see one website, and that simply, it cannot be done. Just think about it. Once you, the stuff you need to actually check, when you know there's a system prompt, and the system prompt used to be this, you are helpful, blah, blah, blah. I mean, there are so many different prompts you can test, so many combinations. It's not easy to verify this. And then in the end, maybe you've seen this, it's quite popular around the internet, like, and who will guard the guards? And in the end, the question is, I understand that we are trying to formalize and test ChatGPT. In some way, who will be testing the humans, the testers? Because in the end, we are trying to improve our experience with humans. So we don't want to save time. We don't want to have those doctors lose their work and then just like lounge somewhere. We want to get a better experience. And then in the end, how will we test how well we're performing right now? What's the baseline? We don't know that. This is not my expertise, but I had some help and friends, so hopefully I'll be able to rely on this. You know, I'm sure you know by intuition that pharmaceutical regulations are horrifying, long, you know, a lot of money goes there. And as I was told, there is something called an investigative brochure or drug dossier, which is something that that is commonly given to a regulatory agency. In the US, it's called FDA. In Serbia, it's called LLMs. In Europe, it's EMA, and they all have similar regulation. The small ones, we copy stuff from the big ones. And I actually went through FDA regulatory process for medical devices twice. I didn't. It's much easier than the real drug, than the stuff you actually take. inside your body. There are 5 sections. They're not important. The quality is probably the major one. Then you have information on your testings, preclinical, clinical, so lots of stuff going there. It's first of all, it's confidential. It's just between the regulatory agency and the applicant. In theory and probably in practice, because it's bought and sold. It's not, you know, when they say data, it's like the new gold or something. This really is gold. So yeah, like available now. And then it's large for generic drugs, which is all tested and seen. So it doesn't have original testings. You just show non-inferiority of the drugs, right? It's around 2 gigabytes, mostly text, not a lot of other kinds of media. It's large. For those of you who know that you can actually upload files to your own GPTs and stuff, it's a lot of data. So use case 2, when you talk about regulatory documentation of some sort, this is kind of an offering we were giving to a client. I stole this from my sales, hope they won't mind. We are aware of all the things that we can basically improve with ChatGPTs. And we were focusing on the labels, you know, all the information you get included inside. That should be some sort of a summary of this whole investigation brochure. It's good for you can track changes, you can track everything going on in the regulatory world. But then there are a few problems that were pointed out to me. So first of all, confidentiality. This is standard, right? Even companies which are not as big as pharma, they simply require you to be offline. You don't share any information with the model authors. It's very expensive to make a mistake. So anything leaking is much more expensive than even the regular IT companies we're thinking about. This offline execution, it's standard, but it's so much easier to use Hugging Face if you use that. It's setting up this model, it's difficult. And then when you ask like, okay, but how many models would we need? What's the scope of this confidentiality? Is it just for you? Is it for your team? Is it for the whole company? Like how many models would we need? How personalized would it be? We agreed on it probably could be 1 per sector, so for the regulatory sector of one company. So it's not, and it makes sense because this is the similar kind of group of corpus of documents that would be used. In my opinion, this is doable, but it needs some kind of framework. It's not supposed to be a custom solution each time for every regulatory sector. And then it's questionable, like how do you generalize knowledge from each case? Because obviously it's not, you know what administration is like. It pretends that it's all going smoothly, just gather all of this data and it will all be okay. It's not. There are always different use case problems. There are ifs and elses. It's a difficult job. And so it's a question, how do you generalize this without harming this confidentiality? How do we take into everything that's been going on and make it kind of available without spilling the beans, right? Then confidence in terms of accuracy, quickly. So how do you validate? And then if humans check, is there a way to validate it once and then say, yeah, okay, this method works, I'm not checking it anymore? Or do you have to validate it every time? Is this general information? I've been told that it's useful. So you can ask, like, what's the protocol for something that's well known. It's similar to Googling, so I'm not sure it's useful. And then for specific information, that's the problem. Like, can I use another LLM as a critique? Can we do layers of validation? And then in the end, do we need to know the difference between different inaccuracies? There are lots of documents that are not maybe visible to ChatGPT, lots of regulatory agencies, lots of stakeholders involved. It's very natural to expect that ChatGPT doesn't have this information. So people sometimes they focus, and I think this is a fantastic approach. They try to distinguish ignorance from hallucinations. So is ChatGPT hallucinating because of your bad prompts? Did you set it up to go wrong? Does it not know, so it just fills the blanks? Is it some other reason? If you understand, maybe you can predict it. So there is a fantastic paper that's basically, again, laying the groundwork for this. and I do feel that this is worth exploring. If we could distinguish between random hallucinations, and this document is not available to me, I think that this is a big step forward in implementing, reducing this toil. And then this is, in conversation with my friend who does this, the practical issues are, how do I explain these specific situations I'm having? How do I present additional company data? So sometimes it's the context we're going back to, not the medical hospital one, but business one. How do I count in the human factor? Because in the end, it's always human driven. You have a person you are talking with in the FDA, in your regulatory agency, and they do have some decision power. There is some how would you say, non-deterministic stuff going on there. And then in the end, my friend repeated several times, I don't know how to explain what my problem is. And this is the point, like in the end, how do you relay this information? How do you do prompt engineering in this case? For the next use case, we're talking about patient triage. Triage is a standard use case where you have to select any kind of patient, like difficult ones, from urgent ones, from non-urgent ones. In this case, this is a business, it's not a hospital setting, this is a different kind of thing. This is basically a client that approached us asking for processing of call center information. So in the US here, I'm not sure if you know this, so pharmacovigilance, whenever you push a drug to market, you have this post-market phase where you're constantly monitoring all the adverse effects going on and people are reporting stuff to you. Very important, and you are tasked, every company has to take care of their own medication. In the US, everything is kind of optimized for business, right? So you don't have your own call center, you have huge call centers which are basically, everything converges there and they are like pushing back all the information to the companies. It's a good idea, mind you, because if your drug is good, probably it's not somebody reporting that every 2 minutes. And then how it works, doctors are actually well paid in the US, not in the Balkans, and medical time is much more expensive than regular call center person. So what happens is they go through a conversation and they ask all the questions like, is your prescription filled? What's going on? Do you feel okay? Are there any adverse effects that you're feeling? And this is the point. Those people, first of all, they come in different levels. Sometimes they don't hear their patients, or sometimes people don't respond correctly. There are lots of things that can go wrong when you are talking with regular people, right? And they do need to include the medical to weigh in. So they're wondering, can we somehow use the sound recording, the sound snippet, and basically do a triage, what should be sent to a doctor and what shouldn't? Those talks are, by the way, very long and kind of, they're not cheap to go through. This is what we were doing. This is just a compilation of our proof of concept. So first of all, there are quite a few problems there. When you first do the speech to text, much of it is lost. Sometimes you have two channels, you can separate the speakers, sometimes not. You just get a jumble of conversations. Stuff is misunderstood. And then this is something that happens, if you saw in that, you can get ChatGPT to hallucinate by prompting it incorrectly. This is one type of hallucination. So you convince it that something, it doesn't have knowledge of right and wrong. It's the game of probabilities, right? You can induce it to go wrong. And this is what happens when you get the wrong transcription. This is actually Llama 2, and this is kind of an old project. I cannot repeat it now because I don't have access to data. I kind of anonymized it, but as you can tell, sorry, this is kind of small. You can see, hello, my name is Brittany. I'm calling from pharmacy on behalf of the Gen and Tech, blah. And then you have to say, okay, so we're setting up delivery of the Allison's bra. This is, I have no idea what this was supposed to be, but Allison's bra came up somewhere in this conversation. This is obviously wrong transcription, and then you have the whole conversation up there. And then what we said to Llama 2, please just include these 9 symptoms. So headache, nausea, vertigo, things like that. And then we said, what are the medical conditions you found? And then it found COVID-19, correct, allergies. Neither of those were in the list, I think, but they were medical conditions. And then constant, as in medication for this condition. Then, of course, bra, and then in parentheses, Allison's bra, specifically, not any bra. And then as a fifth, it's health. And then as an explanation, which explains nothing, in reference to the patient's overall health and any changes that may occur. Obviously, we didn't proceed with this. We found this to be painfully lacking of accuracy. But there are different aspects. So before we dropped it, there were other interesting things. So for example, medications. It did have Actemra, which is medication, and then FedEx, Advantix Pharmacy, Genentech Patient Foundation. These are all medications taken by somebody. So as you can, and then there's an address like North Wales, PA, something. It all went horribly wrong. So the point is, it would be interesting to know like how to handle these inaccuracies. It's not the same. Not knowing is not the same as being prompted to hallucinate. This is a very interesting use case that I think should be explored further. We, of course, didn't have time or energy. Llama 3 is out. I have a friend who's working with it. I'm looking forward to seeing what the improvement is, and I'm sure it's very useful. And for now, for use case number 4, none of that actually worked so far. I think not because we couldn't do it. The technical solutions were basically fast, and I think everybody delivered very well. But then let me give you some introduction. Actually, whenever you work with biomedical data, so there is the commercial setting, and the confidence level is, of course, infinite, especially when you have genomic data as well, because with genomic and then your phenotypical data, you literally, you have everything. You can build somebody. Like you have the blueprint, and then you have all the things that you should have by building this person. And it's as a research scientist, it's very difficult to find sufficient databases, data sets. You have to apply for stuff. And then in the end, even if that's okay, there's confidentiality, you have to apply, you have your principal investigator vouching for you, that's all cool. But there is another aspect, I think. It's the data is not fair shared. So it's not findable, it's not interoperable, things like that. And this is a huge problem. So this biological data, it's very heterogeneous, and the databases are diverse. They're very, very different. And whenever you have a project where you are not gathering your own data, and just so you know, maybe you're not aware, I work with genomic data. Sequencing is insanely expensive. This is kind of obscured by the fact that you have commercial sequencing available now, especially, just so you know, this is the time, Black Friday, you can get sequence for like $60 online. It works okay, the report sucks, but you can actually get some good raw files that you can process yourself, or somebody can process it for you, like me. We can discuss your genes, but the point is, when you do this in a proper, reliable setting in a lab of some sort, it's a few €100 per sample, sometimes thousands, depending on the quality and depth you're using, and this is all. It's very difficult to do it yourself. This was recognized. There is something called an SRA, for example. This is the biggest database of genomic data available out there. And I feel that we rely on it so much, but it's fragmented, and there are so many different entities. It's difficult. You have to write so many wrapper scripts every time. Then you unify the data with something else, maybe some cancer data that you're taking in from elsewhere. The data might be multimodal, so if you need some imaging, it's a huge pain, and definitely it's not fair. What I'm it is findable if you know where to find it. I'm not sure what that qualifies findable. It's definitely not interoperable. And just so you know, since these projects, they're frequently, I wasn't sure how to say it, they're not privately funded, in a say that they're all from some research initiatives, which means that it's all in the end taxpayer money. It's all given, it's supposed to be given to free science, and there's always this talk, let's empower our scientists, things like that. None of this is actually happening. So what is it that we can do about it? I think that first of all, we keep doing that. We want to take one standard that should be overarching. If you read XKCD, you might see that he joked with that, like, oh, there are 15 standards, let's make one to unify them all. And then the next slide is like, we have 16 standards now. So this is, again, I will be that guy. But we were thinking it's difficult to choose a standard because obviously each standard is addressing a issue of some sort, right? Schema.org, I'm not really good with semantic web. I was just introduced to that. But you know those triplets, and they're supposed to, like an ontology, describe the relationship, like adding predicates in between. So this kind of schema is good because you have all these entities. That is actually the real benefit of this. So everything that actually has a DOI, everything online can be a schema.org object. Not really everything, because biological data kind of has its own problems. And then we have bioschema.org that actually extends it for biological data. You have validates, you have awesome stuff. As long as you understand what item to map it into, you can do the mapping. And I think this is a good choice for an overarching standard. We started doing this project, so this is not a client base, this is like basically an open source initiative, testing it if this can be in any way made available to scientists. So when I am using specifically ChatGPT, I'm sure that any LLM can be used. So first of all, ChatGPT does know bioschema entities. Schema.org as well, but bioschema knows it very well. And it's interesting, when you have it select an entity for you, sometimes even if it mismatches your own opinion, it usually does it better than you. Because in a way, you see the sense. It knows what people have been using around the internet for some reason. So there is logic behind it. It's not usually, in my experience, it's not a hallucination. It's actually an insight that you can have. So its mappings are always kind of informative, and then we can discuss it. Then actually LLM, they do know, as far as I can tell, the original metadata schema. So these are all for the 8 biggest databases that I've currently explored. It actually does know what kind of fields it has, and so the mapping kind of can be done easily. Then there has to be some sort of code that has to do it. Somebody has to write the transformation code and schemas. And I can tell you, first of all, there's not a lot of custom code needed. I employed the JSON converter, the Python package standard. It's well explained, but I'm not sure if it's big enough. It doesn't, first of all, ChatGPT is handling that very well as well. And then, you know, when you can upload your own files, the amount of custom functions and decisions, it's not very big. So for example, we have one, if you worked with online responses, you know how annoying can it be that something can be either an object or an array of objects, and this is a frequent problem for us. So for example, if you wanted to use the third element, your own custom functions, that's quite easy. And I can tell you that for those databases, we had virtually no hallucinations. So for me, this is something that I will be reporting on, but I feel that this is also a very viable use case, and the first one I've seen that can be done now for large language models. And that's it. Thank you.
HTEC.